Hey everybody, I'm recording this screencast because there's a topic that I haven't been able to cover so far in the course, and it has to do with the main method in a Java program, and really what it's all about, and I think more importantly, how you can test it. As you may recall, with the when we talked about how to test your program, we talked about the importance of being able to exercise the main method. I didn't show you how to do that. I'm going to do that now. And I'm going to be working with a student class. So as you may recall, a couple of classes ago, we created a student program. We did some test-driven development with it. You all did an exercise where you went and brainstormed some test scenarios for it here with this document. In class, we focused on this first set of test scenarios, which is all about working with the student class itself. And if I go back to IntelliJ, right, we wrote this student test, unit test, and we just worked through a couple of examples here using just plain old JUnit tests that are methods that are annotated with @test, and they have that given when then, sort of where you have a setup of some sort. Let's take a look at this test down here. This student toString contains this class is too much work. This one right here. Um, we set up the test by creating a student with a name, and then we make these assertion statements. Right, these come from the Hamcrest API. You can read all about it in the JUnit lecture, um, where we have this kind of fluent language for expressing assertions. We say that assert that some behavior, the result of some behavior, like invoking the toString method on our student object, contains a string. This class is too much work. So this is a unit test. This is what you do here. You set up some code, you perform some operation, and then you make an assertion about what you expect to have happen. And with test-driven development, what you do is you write the test first, you see the test fail, and then you make the test pass again. Right, that red-green refactor cycle, Uncle Bob with his hat. So and we went through and we did that on a couple of these tests. And then we refactored it by extracting methods like create student named. So that's the red-green refactor cycle. We'll be seeing more of that. We'll be focused on the main method of a Java program. So let's just go over here, look on the left at the source code. Right now, our main method is very simple. It just prints missing command line arguments. And I want to show you how to invoke a main method from the command line. So here we are in our code checkout. We'll go into the student directory. We'll just work from there. The first thing we need to do, the way we invoke main methods from the command line in this course is we use what's called an executable jar file. So a jar file is, I'm just going to hide this other window right there. Can't get in my way. A jar file is is a file that contains class files, resource files like the readme.txt, stuff like that. As a matter of fact, let's just take a look at it. You build um, a jar file using either you build it using it's built by Maven in the package phase. So more details about this are covered in the Maven lecture, which is in a couple of weeks you'll get all the details, or you can of course watch it now. But the package phase is the thing that assembles whatever artifact is built by the Maven project. In this case, a jar file. And package happens after the compilation phase and the unit test phase. As you can see, it went through all of that. Oh yeah, right down here at the bottom, it says that it's working with this student version 1.0.0 jar, and so then we can take a look. We can see that file exists. So student.jar. We can use the jar tool, which is just like the tar tool. So we can say jar tf for table of contents for the file. That oh wow, it's got all sorts of stuff. Let me click pub into less so we can go through it more easily. So this is what's in the jar file. All sorts of stuff. Oh, it's interesting that it has all the koans in it. No, sorry, these aren't the koans. Oh, okay, this is just my code, which is all, yeah. It's all merged into it. So it's a standalone thing. You don't need to put multiple jar files on the class path. The most important stuff is here at the top. There's something called the manifest, which describes um, which describes the jar file, and actually we'll take a look at that in a moment too. But this is probably the most important thing right here. So it has inside of it, it has the student class, right? This is a super simple Maven project. It's really only got one class in the main, right? If we go back and look at the project here, and we'll go into student, we'll see that the source main just has the student class in it. Very simple. And so then the jar file just has the class file for that, right? The test code is not included in the jar file because the test code isn't code that you ship, isn't part of the application. It tests the application. So it's not included inside the jar file. All this other stuff are the dependencies that of the project that are included in the jar file. So again, it's all self-contained. So it has my example code. It has it's a family jar. It's got a lot of stuff, right? So probably this stuff doesn't really need to be here. These are all transitive dependencies. In a real world project, you'd want to be much more careful about this because there's no reason to ship a bunch of code that ultimately isn't used. Wow, there's a lot of stuff in here. That's kind of neat. Okay. There's one other thing that I want to point out, and that's this manifest file. So I'm going to extract that file so we can take a look at it. I'm just going to create I'm just going to go into the target directory and do this. Well, I'm working from the target directory because target is the directory in Maven that contains all of the compiled artifacts, or well, all of the outputs of the build, if you will. So we've seen some things like this before. Clearly the jar files here. All your class files for the project are there. Things like the test code is over in test classes, and then you've got things like the Surefire reports, which have the output of running unit tests. Anyway, all this is covered in the Maven lecture. That does not. We want to focus on the main the main method instead. So we have the jar file here in this directory. So that was student 1.00 jar, and we want to open up the manifest file. So we want to extract from that file student.jar, and the entry we want to extract is the metainf manifest file. And now if we look at that, we see it's got the following. All sorts of information about the jar file itself. And there's one very important line in here, which is the main class. So the main class for this jar file is the class whose main method is going to be run when you do the following. So when you say java-jar, I'm going to do this from the parent directory because this is what you usually do. You say target student, you say java-jar and then this jar file. You run this and it prints missing command line arguments, which is exactly what the main method does here. It prints missing command line arguments. And the reason it knows to run the main method of the student class is because that's what's mentioned up here in the manifest. So this is how everything's hooked together through the manifest and this entry, this main-class entry in the manifest. One more thing I want to point out here about the jar file. If you look in the pom.xml for the student project, there's lots of stuff in here, but the important thing is, let's see here, you probably want to look at the jar plugin. Yeah, here it is. So this is the configuration for Maven, and there's a plugin for Maven that controls the jar file that's created. And you can configure the manifest in the jar file to have this main class, and this is the main class for the student project. I point this out because in your airline project, if we go look at the pom.xml there's a similar entry for, here is the project 1 main for the project 1 main class for the jar. When you go to project 2, you're going to need to change this entry to refer to the project 2 main to make sure that when you run java-jar with the jar file, that the main method from project 2 is executed. So that's more about the jar file. Again, the most important thing to know for right now is that you execute the main method from a jar file by saying java-jar and give the name of the jar file. It's all self-contained there. And I think, you know what, I might show this before, but I just want to reemphasize sort of how the build process works here. Um, if I make a modification to the main file, I need to rebuild. Well, then I go to run it again. It's not going to see the modification. There aren't two stars there because it hasn't been rebuilt. So then you need to rebuild. And as long as you execute any phase of the Maven project that runs the package phase, it'll be rebuilt. So if we run package again, so if we say Maven W to invoke Maven and say package, this will rebuild the code. It'll notice that the student file has been changed. It'll rerun the unit test just to make sure the unit test still pass, and then it'll create the the jar file. Okay, and now when we run java-jar again, now we see it has the two dots. So this is an important concept to understand, that when you modify the source code, you'll need to rebuild the Maven project in order to see those changes being made. And rebuilding the Maven project executes a number of phases. It'll compile the code, it'll run compile the source code, compile the unit test code, run the unit tests, and when you run Maven package, or well, I'll talk about Maven verify here in a moment. It'll rebuild the jar file. Okay. So a little bit more about main methods. Now, main methods have, well, I mean, they're methods. They have inputs and outputs, but they're a little different than a method like says or toString, in that the inputs to the main method are, in the code are an array of strings, but really the inputs are arguments on the command line. And actually, let me have another example here. This prints it, it's in command line arguments, a standard error. Let's just change it to echo back the first command line argument that you give it. And so just so we can see how the command line arguments work. So we're going to say the following: if args, if the number of command line arguments passed on the command line, args.length is greater than 0, so if any of are passed in, we're going to do something. Otherwise, we're going to print missing command line arguments. And what are we going to do? We're just going to print the first one, and we're going to print it to system.out. So system output, or standard output, as well as a standard error. And we're just going to say first argument, and then is args.0. Oops. Oh, just a little laggy this morning. Okay. Once again, I got to rebuild the project with Maven package, and then we'll be able to see the what the program does now. Okay, so we'll run it again with no command line arguments. It says missing command line arguments. We'll run it with hello. We'll say the first argument was hello. So this, what I'm doing here is I'm showing you how the main method is interacted from the command line. And what you do is you pass in arguments, and you and then, well, sorry, what happens is the user, the person that invokes the main method, passes in command line arguments, and then what the program does is it's some logic, but ultimately the way it communicates back to the user is that it uses standard output and standard error through the system.out object and the system.error object. And these both have print line methods on them, and they're actually output streams, and you can learn more about that in the I/O lecture. So that's how main methods work, right? They take command line arguments, they do something, and then for this course, what they primarily do is write to standard output and standard error. And right, you saw this in your in your project one assignment. What it does is it manages the airline application based on the command line input. And as I said when I introduced project one, the really the interesting part or the challenging part of the project is to implement the main method, not so much the other methods. Let's say you implement a main method, but how do you test a main method? Because even though this is a Java method, you can just invoke it. Um, you can't. How do you verify that the correct output was written to standard out or the correct output was written to standard error? Um, you can't do that with a simple unit test. You can invoke a main method, but so I could write a test which is void try to invoke main, and you can do that. You can say student dot main, and they can send it some arguments. Um, and then with you know hello, right? So this is basically what we do on the command line. You can call it, and then right, main is a static method. So this is the way you invoke it. It's a static method of the student class, not an instance of student. Um, uh, but and you can run this and it'll pass, but you can't get at what's there in what's written to standard output and standard error, and that's what you want to do, right? Because I mean, how do you know that you are correctly handling the command line unless you validate that when you provide certain inputs, that the expected output is written? So right, there's nothing here. So I can't write a test for like saying, hey, if I don't put any arguments, please print out or make sure that missing command line arguments is printed. So because I highly value test-driven development in this course, I wrote a framework that allows us to do this. But because I'm trying to get rid of this here. I can't. Wow. Yeah. Huh, I'm sharing a portion of my screen in Zoom, and it doesn't seem to be too happy right now. I might need to change that. Anyway, um, there is, uh, if you look in the student project, we saw the student class here in the main code. We saw that there's a student test unit test off in the test directory. And then there's another directory called IT, which stands for integration tests. So there is another type of tests called integration tests. I think I might touch on this before, but I want to go into a little bit more detail. Actually, it might be in the handout now I think about it. I'm going to go down to the very bottom. Yeah, unit tests and integration tests. So, um, so before I get back to the main method, I want to talk about what integration tests are all about. So unit tests are meant to not only focus on a single method or a single class, they're meant to be fast. They're meant to be very lightweight, right? It's just code running code. More importantly, it's not supposed to interact with anything that might slow the test down because we want your unit tests to give you like very rapid feedback. And you want to be able to run them every time you make a code change. So, I really like this list of sort of anti-patterns or like smells that shouldn't appear in unit tests. So, like if you have some code that communicates with a database, makes a network call, works with the file system, has to be run sort of independently of other unit tests, or if you need to like set up, do a whole bunch of expensive configuration, like setting up files and stuff like that, shouldn't really that's not a unit test. That's more things. Really, that qualifies more as an integration test, meaning that it is a test that integrates multiple parts of the system, not just a single class or a single set of a small subset of classes invoking each other. So I mean, this is good. So as you write your unit tests, please keep these things in mind. And one of the things that as your project gets bigger and bigger, you'll need to figure out for any piece of functionality that you want to invoke. Any piece of functionality you want to test, does it make more sense to do that in a unit test or in an integration test? So, you have unit tests for doing the quick and straightforward things, but like I was saying a moment ago, what should you do when you want to test something like your main method, where it's not easy to do or it doesn't really fit nicely within the JUnit framework? Well, that's where you can use integration tests. And not only is it an integration test, but an integration test that uses this framework that I created. So again, in the student test class, this is where we just invoke methods like the says method or the toString. The main method, though, we need to have a different kind of test so that it's able to interact with standard output and standard error. And really, by interact, I mean figure out or determine or make assertions about what was written to standard output and standard error. And all of that is in the student IT class, so student integration test class. And it uses a class called invoke main test case to be able to run the main method of a program of a Java class and capture the standard output and standard error so it can make assertions about it. So let's take a look at the student IT class. Out of the box, it comes with one it comes with one test, and it says invoking main with no arguments prints missing arguments to standard error. So our student IT class extends invoke main test case, and this is a class that I wrote. It's one of it's often in my code base, and it gives you an invoke main method. And so you call invoke main with the student.class, right? This is the meta class. You probably saw this in the koans. This is the meta class for student. And this uses something called the reflection API, which allows it to dynamically invoke the main method on student. Don't worry about that now. Just know that the way that you invoke the student class is by calling invoke main. And then once you do that, you get this result object, which is an instance of this main method result class, which is declared inside invoke main test case. And you have this main method result, and it has methods like give me the text that was written to standard error. And so here I'm using a plain old ham crust assertion to say, hey, make sure that the text written to standard error contains the string missing command line arguments, which is, I think we would still expect that, even though I added the 2 stars there. Yeah, it still has missing command line arguments. So when I run this, this should pass. Oh, oh, look at that. No tests were found. Oh, yeah. Okay, this is cool. Um, I'm glad we ran across this. This is a common error that happens when you go back and forth between the command line and IntelliJ. I'm pretty sure you can get rid of this, and you found this error because you see this test ending with ID JUnit Jupyter failed to discover test error. I think if you just do a Maven clean, it should be okay. And I'm pretty sure this is mentioned in the testing handout also. So I've done that clean over there in Maven land, and now I'm going to, I just rerun it from here, or do I need to rerun it from the source code? I couldn't remember. Oh, good. That passed. So again, what we did here was we used invoke main to invoke the main method, and we were able to use, because we used invoke main, then we could get the text that was written to standard error and validate, assert that it contains what we expect. I'm going to write another test, I guess that tests that, let's see here, first command line argument is written to standard output. And what this is going to do is it's going to test, basically this stuff here on line 63 and 64. So again, I'm just going to copy this code to invoke the main. This will probably be a good candidate for refactoring here. And I'm going to assert that the from the standard output contains string. Oh, I need to invoke it with an argument, don't I? Yeah. So in the invoke main, if you look at the signature, it takes a class and then a variable length array of args of the arguments to pass the command line. So here I'm going to pass in the string, oh, I don't know, test. Doesn't matter what it is. Oh, I'm going to assert that it contains the string test right here. So this is what you would pass on the command line. So this is essentially like invoking, I don't have it built here. This would be essentially like invoking the command line with the test. This isn't going to work because I cleaned the Maven repository and therefore the jar file doesn't. I cleaned the Maven project and therefore the jar file doesn't exist anymore. Okay, now I'm going to run this test. I'm not doing red-green refactor here because I started the demo with changing the main so you could see all of that. But okay, good. That passed as I expected. Even though I didn't do red-green, I do want to do a little refactoring. So I have this constant test here twice. I am going to refactor it by extracting a variable for it so that it's only used once. And I want to say, yes, I want to replace all 2 occurrences of this. And I just want to call that, arg. And I'm going to run the test again just to make sure that it still passes. It ought to. But this is pretty common where you have some test data in a test and then you use it in the the when clause. So you invoke the main with that argument, and then yeah, you assert that argument was printed in standard output. Cool. Okay. Well, so this test actually isn't the behavior that I want because as you may recall, the behavior of the main method, which we captured in a bunch of scenarios here, um, is to provide some command line arguments and then yeah, then have it output various things to have it write various things to standard output and standard error. And so yeah, so let's just take a few minutes here and implement some of these things as integration tests. So let me just take a look at these integration tests and figure out where I want to start. You know what? We didn't really dive into these in class. This is pretty interesting. Like what some of the things came up with. This is really cool. And I'm looking at it, and not surprisingly, most of them are negative test cases. So this is error handling basically, which actually I'm really glad that you all focused on this because this is like what you'll be doing in your project 1 also. The reality is that because there's such limited functionality in project 1, most of what you end up doing is handling error scenarios in your main method, and that's perfectly fine. Actually, that's part of what the project is all about, is to give you experience doing exactly that. Don't worry, it'll be much more interesting in project 2 going forward. We'll be doing things like writing to a file and formatting text, all sorts of good stuff like that. Okay, which one do I want to do first? You know what? We could do this first one first. Maybe that's kind of interesting. So if we go back to the unit test, remember there was this Dave student where we where we basically create a student object which is fully complete. It's got everything. It's or rather we create the student object that's got everything, like the name and the classes, the GPA, and the gender. And then we basically do an assertion that all of the functionality in the program has been implemented. So we say the toString value has the whole string. Dave has GPA 3.64, is taking 3 classes, et cetera, et cetera. We can do the same thing in the integration test, and I think that might be valuable. Oops, let's get rid of. No usage is found in files. Oh, there it is. Okay, it just wasn't getting the right thing. Okay, I want to roll back this test because it's not very interesting. And instead, I'll make another Dave test over here. I think, is that what I called it? Student Dave? Dave student. Yeah. I'll make another test here, but instead of testing the student class, the methods of the student, well, the instance methods of the student class, it'll test the main method. So here, I want to invoke main again, and I'm going to invoke it with, excuse me, some args. I apologize for my voice this morning. I'm kind of froggy. Oops. Do need to hit that. There we go. Hide all those funny things. I'm going to create a variable here, and here's going to be an array, string array, and let's see, does that syntax work these days? It does. Okay, so my command line arguments are going to, actually I can just copy that from the assignment here. Yeah, here it is. All these are the command line arguments. I'm just going to put in a comment, and it'll probably make it easier to, there you go, turn these into strings, or maybe it won't. Gosh, I'll just put all these in a string and then go through. So this is Java code for invoking the main method, and so then these are all passed in as strings. And so let's have this array of strings here. I don't need to escape the space here and just put it all in a string, right? So there's like what's there's the syntax for expressing it in a Java program versus the syntax for expressing it on the command line. So here we don't need to escape anything because the Java compiler knows to put that space there. And then what do we want to do? We want to assert that that when, let's see here, that the what's written to standard output contains string or equal to. I think I want to say that it's equal to, meaning that only this text is written to standard output. And then, you know what I'm going to do? I'm going to go over my tests. I'm going to copy. This. I'm going to extract a variable again for this whole string. I'm going to use refactor, introduce variable, and I'm going to call it just toString, or I'm going to call it Dave string. Yeah, I don't know. I think it matters there. I want that here because so I can copy it and put it in the integration tests. So this is the expected toString value, and I say toString. So let's run it and see what happens. Okay, it failed, as expected. It said, okay, yep, I expected this big old string, right? And, oops, instead, go back in. But instead, all I got was first argument Dave, which is exactly what the code does right now. So, okay, that's it. That's what I would expect. So I like having this end-to-end test case because it tells me, well, it gives me the goal, right? It's like this is probably one of the last test cases that I need to get passing. But it's going to be a while before I get there, right? We haven't implemented this this functionality yet, so I'm gonna disable this for the time being. Okay, now let's start implementing some of the functionality inside the main method by looking at some of our test cases. Let's see here. We already have a test. I'm going to mark this as implemented, by the way, just so I remember. Let's see here. Background color. Green. We can use that green. That's green. We already have a. Yep. We already have a test case for that, so I'll make that one green also. Green as in implemented, not green as in passing. Oops. One. Yeah. Okay, so let's see here. Atom mail minus 3.64, enter to databases. Standard error. Oh, throws legal argument exception message. Please enter a valid GPA. So actually, I'm really glad that the error message, or what was written to standard error, was expressed this way, because this is you actually don't want to do this. You didn't know this when we went through this exercise, but if you go back and look at the project 1 assignment, I'm very clear that when an exception happens internally to your program that should not be reflected to the end user. Or the end user doesn't know what a legal argument exception is. It'll just confuse them and actually, it'll be really wonky to them. So you don't want to print that. Instead, I just like just print the error message. So what's put into standard error is please enter a valid GPA. I like this. And so now I want, so I'm going to use this as I think the first test case. So let's see here. I'm going to call it negative GPA prints error message to standard error. Okay, so I'm going to, again, I'm going to copy this. Yeah, it's probably getting time to refactor that. I'll do that one more time. And here, the arguments are going to be, again, just copy this to a comment so that I can look at it more easily. I'm going to say Adam male minus 3.64 and enter database. Nice. So with this, when we invoke the main method, we're going to assert that the text written to, oops, so get text written standard error contains string, and what we're going to call it, we're going to be please enter a valid GPA. That's good here at the end. Okay. And actually, we should probably also assert that nothing is written to standard output. Oh, do I say equals null or equals empty string? I can't remember, so we'll just try that and see what we get. Okay. I'm going to run this test, see it fail, and then we'll make it pass. Yep. Expected, please enter a valid GPA, but was the empty string. Okay, and so I think this is good. It tells me that when nothing's written, you get the empty string back from standard error, which is true because if we look at the implementation of the method, in this case, it doesn't do any validation of the oops, excuse my miss. Doesn't do any validation of the GPA. Okay. So then, what do we need to do here? Well, let's start implementing some stuff, I guess. So we need to parse the command line. So I want to change around the code a little bit because the first thing I want to do is I want to check to see if there are if they're missing command line arguments. So let's just change this so that if the length is 0, then we'll print the missing command line arguments. There's a neat little trick in IntelliJ that you can use if you can say invert the if condition, and then it does it that way. So that way, this code is first because I'm going to change it thusly. Let's see here. This is complaining that it can be replaced with equality. Yes, please. Okay. So basically, I want to say, hey, if it's if the length of args is 0, say missing command line arguments, and then return from the main method, I'm done here. So there's nothing else to do here. Otherwise, well, I'm just going to delete that code because it's not interesting anymore. It's not what I want. Okay. So otherwise, if there is a length 0, I'm going to do the following. I want to extract the GPA string, which would be argument, let's see here, 0, 1, 2. So GPA string equals args 0, 1, 2. And let's see here. I then want to create a new student object. Well, or I need to implement the logic that says, oh, hey, if I have a negative GPA, then I should print the error. And I ultimately want that logic to be implemented in, I think, the constructor, right? This is where we pass in the GPA, and we need just the same way that we validated um, the name. We'll need to validate that the GPA is in a is valid. So I'm going to do the following. Um, well, actually, before I do this in the main method, I should probably implement it in that constructor. And so I'm doing test-driven development. So this means that I want to write a test for this code in the constructor, and that all happen. And because it's just the constructor and not the main method, that should happen in the unit test. So now I'm going to write a similar test here in the unit test. Oops. That validates the following. I was going to say, what is it? Negative GPA throws invalid GPA exception. Well, actually, do I need to say it's negative? I'm going to say negative GPA exception. I'll be super specific here. So let's see here. I need to create a new student object. I can't use the create student named. I don't think I'm going to need a create student with GPA, so I am just going to create a new student. Student equals new student. And oh yeah, I'm going to use that same. Actually, I'm going to copy this right here. Again, the name is going to be. Oops, no. We're going to hit escape. Zoom thinks that I'm. Okay. So the name is going to be Adam. What's next? The classes is going to be create a variable for that shortly, and then GPA is going to be minus 3.64, and then the gender is going to be male. Okay. And then the classes here, I'm going to create a variable for this. Great, it's going to be new array list, and then I'm going to add into the database. Nice, okay. And, oh, okay, right. So I create the new student, and I expect that when I invoke the student constructor with this negative GPA, that it throws a negative GPA exception. So I'm going to have to create a new exception class. And this is actually something that you do quite often in Java programming. We reused illegal argument exception here. Oh, actually, I think we sort of hinted at in the test cases that there should be an illegal argument exception. The thing about legal argument exceptions is very generic, and so then like when I handle it, I don't know if I could. Well, I actually please enter a valid GPA. So this is a good error message for the command line program. It's probably not a good error message for the class. Yeah, I want to create my own exception here. And so then I'm going to use the assert throws when I call this when I call that constructor. So I'm going to do the following. I'm going to say assert throws. It's going to throw a negative GPA exception. Actually, I'm going to put this as an inner class inside of student. Oops. We're going to use IntelliJ to create this class. And it's going to be, yep, it's going to be right there. And it's probably complaining that, well, let me just complete this. So assert throws, and this takes another one of those executables. So it's going to be, I'm going to use this lambda syntax again, and I'm going to say the following. I'm going to say the lambda goes to just creating a new student right here. Cut that here, paste that there. Just need a semicolon. Maybe it's still figuring it out. Okay. And here it's complaining because, oh, it doesn't, it's not throwable. That is true. I need to make it, no, I guess I need to, I need to make my exception extend, exception. Well, I'll have to do a runtime exception. That way I don't have to change all my code. Okay. Oh, what doesn't it like here? Right, it's not static. Great, make it static. Cool. Okay. So I'm being very explicit here using this new type of exception, but actually I think it makes ultimately it makes the code much more clear and expressive. So it's like, yep, this is exactly the kind of exception that is thrown here. So that's the test that I want. So basically, it's saying like, hey, when I create a new student with a negative GPA, I expect that a negative GPA exception is thrown. Can I run this test? Again, I'm writing unit tests. This is very often what you have to do, right? If you focus on doing test-driven development for the main method, then you end up wandering back to your unit tests to test the code that you're about to invoke from your main. Great. It failed because it expected a negative GPA exception to be thrown, but nothing was thrown. Well, let's change that. So now if we go back to the student constructor, let's type out some code. So let's see here. I am going to say throw a negative, I don't know if I like the names of these, but I think it's very clear. Negative GPA exception if negative. I'm going to pass in the GPA, so I'm going to create this method here. And I'm going to say if GPA is less than 0.0, then throw new negative GPA exception. Now I'm going to run my unit test again. Nice, that passes. Okay. Good, it's good that the unit test passed. Now I'm going to go back to my integration test. I'm going to make sure this still fails in the same way. Actually, I haven't changed much of anything, have I? Huh. Nope. It says please enter a valid GPA. So now I'm going to go back to my main method, which is down here at the bottom of the file. And I'll say, great, I got the GPA. And now I need to create a student object. And actually, I don't need to store the value anyway. I was going to say new student. For right now, I'm just going to put in some kind of placeholder data. Classes. We're going to need GPA, and then we're going to need a gender. And I'm going to do the same trick here. I'll create a local variable and just make a new array list. GPA is a little bit more interesting. The GPA is going to be, GPA is going to be here. I need to create, what did I just do? That's funny. Okay, that's not what I expected. Oh, okay. One keyboard shortcut. There we go. So I move it up a line. What am I? 2 lines. And I want to convert the GPA string to a double, so I use double.parseDouble, which is which is basically the double analog of what we used in class up here, integer.parseInt, right? So when we wanted to check if a string is an integer, we use integer.parseInt. We want to convert a string to a double, we say double.parseDouble. And we'll pass in the GPA string. And you're probably thinking to yourself, oh my gosh, there are all sorts of test cases that we haven't written. Like what happens when you pass in, invalid double, what if you pass a string in that doesn't represent a valid double? Well, we'll write a test for that. And maybe we should just do that next after we get this test passing. So we create the, we convert the string to a double this way, and then we'll use this GPA when we invoke the constructor. Now we're invoking the constructor, which is what our test wants to do. So let's run our test again and see how it goes. Oh, huh, I know what's going to happen. We didn't catch the exception. So okay, now we should see that it throws the exception. Oh, great. Oh, actually, I'm glad I did this because it shows up the following in the invoke main test case framework. So over here when we're writing integration tests, the following occurs. So remember I was saying a little bit ago that your main methods should not show evidence of an exception being thrown. Because again, if the user sees a stack trace, it's just going to confuse them. So the invoke main test case framework has the following behavior. If an exception is thrown, then the test fails with this uncaught exception in main with a method saying, with a message saying main method should not throw exceptions. So this is an indication to you that your code needs to catch an exception. And we do that right here. So we'll say the following. So we put our call to the student constructor in a try catch block, and we'll catch a negative GPA exception. And in this case, what we want to do is we want to print an error message. And what was that error message? And please enter a valid GPA. I'm just going to copy that over here. And we're going to return from our main. You might be tempted to call system.exit. Please don't do that. Actually, I'll show you what happens when you call system.exit. Actually, first I want to do this so we can just see it pass. I think this will make it pass. Yep, that made it pass, which is good. Now I'm going to call system.exit just to show you what happens when you do that, because it's not something you want to do. We'll say system.exit1. Oh, interesting. Okay, so it didn't pass. So it said no test pass, and it said process finished with exit code 1. This is not what you want to do. I thought it would actually it'd be a little nastier than that. Let me run all of the tests to see if we get a different behavior if we run all of the tests here, or if we run multiple tests. I was thinking that the test failed in a more interesting way. Yeah, like they all, that they all are not run or something bad happens there. So so basically, bottom line is that you don't want to invoke system.exit in your code. Instead, nice. Okay, so we have our integrations test passing. Let's also go and run all of our unit tests again. All of those are passing from IntelliJ, so this is good. So it's good that everything's running from IntelliJ. However, your code isn't graded from IntelliJ, it's graded from the command line. So I want to go back over here, and now I want to run Maven again, but I want to run the verify. I'm going to do a clean, and I'm going to run the verify phase. Now, what the verify phase does is it does like an end-to-end build of your system. Since I did a clean, it will delete all the artifacts. So then it'll go through and recompile the source code, run the unit tests, build the jar file, compile the integration tests, run the integration tests, and verify that the integration tests all pass. And they did. This is good. You want to make sure that things run from the command line, that your project can be built from the command line, because ultimately that's what's going to be verified when you submit your code. And I test it. So you want to make sure that everything runs end to end. Okay, awesome. I think we're ready to check this code in. So this was kind of a journey. I just want to review, what we did. So we talked about the student integration test, the student IT, and this uses that invoke main method to call the main method of the student class. And you pass in what are essentially the command line arguments to the main method, and then you verify that the text that you expected is written to standard error and standard output. And then to get these tests to pass, you implement the logic in your main method. And this is relatively straightforward. But as you add more tests, it will get more interesting, more involved. So, and I think it was also important to note that as we began implementing our main method, we realized that there was code in other methods, like the constructor, that needed to be written. And to test that code, it made the most sense to write a unit test first because it was focused on just the constructor. And then we went back to our integration test and our main method to then invoke that code. And I guess that's really what an integration test is, right? Where the main method integrates multiple methods from the student class, multiple other methods, multiple instance methods from the student class. Okay, I'm going to commit that. And then I think we'll implement one more integration test, and I think that'll be good enough for now. So I'm going to say throw a negative GPA exception if the GPA is negative. Because ultimately that was the logic that we implemented. Validate this functionality with an integration test. Push. Got some warnings, but okay, push it. Let's see here. We talked about maybe the next one we should do is like an invalid GPA. So let's do that. So we did negative GPA. And void invalid GPA prints error message to standard error. So I'm just going to copy all this again. Go from there. And here the GPA is going to be, it will have to be the string invalid. And let's see here. I think, what do I want my error message to be? Actually, is this a test case? I'll go back here. I should mark this as a test case that has been implemented. It hasn't. Do we have an invalid GPA? We don't. Oh, interesting. Oh, this one is too large, but it is not. Yeah, it is not syntactically erroneous. Okay, awesome. So then I'm going to, let's see, I want my error message to be the following. I want to say GPA invalid is not a positive number. Well, is not a number between 0 and 4.0. Nice. That's what I want my error message to be. Okay. And so I'm going to do the following. Actually, that's my test. I think it's implemented. Yeah, it's implemented the way I want. So I'm going to run it. And let's see what happens. Okay. We get another one of these main method should not throw exceptions messages. And it says caused by number format error for input string invalid. And so sure enough, here my stack trace, here on line 77, yep, I try to parse my GPA string. My GPA string is invalid. It throws a number format exception. Okay, so now I need to catch that number format exception and handle it accordingly and print out this GPA invalid is not a number between 0 and 4. Okay. So I need to catch the exception. I'm going to do the following. Let's see here. I want to wrap this in a try catch, but I need to keep the GPA variable available for this code down here. Oh, I know what I can do. I can extract this into a method. I'm going to do that. I'm going to extract a method here. I'm going to put the error handling. No, actually, no, I can't put the error handling in that method very easily, can I? Never mind. Okay. Oops. It's more. I'm going to do a little trick, another nice little IntelliJ thing. I can say split declaration and assignment. So now I've got this on its own line. This makes it much easier for me to wrap it in a try catch. And I'm going to catch this number format exception. Number format exception. And if I get one of these, assume I'm glad that you're showing the meeting controls, but I want to escape to do something else. If I get a number format exception here, I want to print an error message. Let's say print line. What is it? GPA. I'm just going to copy this whole thing. And that string invalid is actually, I want to replace that with GPA string. So what's the easiest way for me to do that? I'm going to extract a variable here. Actually, I'll just do this. I'll delete this. In 2 quotes, I'll say GPA string. Yep, I think that's right. I'm going to run it again just to see if that works. Oh, variable GPA might not be initialized. Oh, that's interesting. So let's see here. It's complaining that this variable might not be initialized. Let's see here. New GPA. Look at this. Okay, so I catch the number format exception. I print, I print a standard error, but you know what? The code will keep on going. And so then it will go and execute this line. It'll try to execute this line, and it's true. If the exception is thrown, I never assign a value to GPA in the catch block. And so what I should really do here is I should just return from the method. Oh, good. It seems happier now. Okay. Yay, compiler. So that's one nice thing about Java, right? You can't have an uninitialized variable in Java. In the test pass. Sweet. Okay. Now, I'm going to commit this code, and then as a little commentary on the way my main method is shaping up. So print an error message if the GPA on the command line is invalid. Okay. So let's see here. I think this is enough coding for now. This screencast is probably going on for way too long. But I think I want to leave with just saying a couple of things about the main method that I'm building here. As you're probably noticing, there's a lot of error checking that I'm not doing. For instance, hey, what'll happen if I have if I pass in just a single argument, right? It'll blow up right here on by trying to index into the array, the second element of the array when there's only one element in there. You'll get an array index out of bounds exception or something like that. And I'm okay with that. And I'm okay with the state of my main method because of the following. I'm doing test-driven development. So like when I see issues like that, I should resist the urge to like implement something before I have a test for it. So really what I'm doing in my mind, and actually if I was doing this for real, I'd be writing this down on a piece of paper or just having maybe like a comment in the integration test like, oh, here's more things I should test. So it's not so much about what I should implement, it's what I should test. And so then maybe the next thing that I do is I validate that a missing GPA prints out a message. And that way it would force me to write the code that checks the length of the array to make sure that I have enough that enough arguments haven't passed on the command line. I realize that might feel like really unnatural, but this is part of the discipline of test-driven development, is to say, listen, I shouldn't write a single line of code on the left in my source, in my source code until I have a code on the right in my test that invokes it. And while again, it might seem a little awkward at first, there are some real benefits. And the biggest one is that that all of the code that you write on the left is covered by a test. You'll have complete test coverage, and because you have complete test coverage, it behaves the way that you expect. or at least behaves the way that is captured in in the tests, in the automated tests. And there's a lot of value in that because you know your code will work. Okay. Okay. Well, that's enough for now. Thanks everybody. I hope this was informative. You're going to need this for your projects. You'll be writing integration tests because that's like the only way to get test coverage of your main method and validate that it's doing the right thing. So hope everybody has a good weekend, and I will see you in class on Wednesday when we'll be doing some more pair programming. Thanks everybody.